All right, this is 2.2 elementary functions. We are only going to be looking at piecewise functions. Piecewise functions are functions made of different outputs or pieces with different restrictions, right? So it is important to know how to read a piecewise functions. The restrictions on a piecewise function tell you which part of the function you can use, or which part of the piece, which piece of the function you can use, so you can evaluate it. Okay, so we'll be evaluating piecewise functions, we'll be graphing piecewise functions, and then we'll definitely have an application for a piecewise function. So let's try example 1 out. This says, for the function defined as f of x, we get x plus 1 for all values of x less than -2. So this means that for any x value less than -2, we can use the function x plus 1. Okay. Then next, for any x values between -2 and 3, the y value, the output, will be 5. Or we can use 5, right? And then for any x values greater than 3, we can use the function x squared. This is how we read the piecewise function. Okay, so down below, we are given x values. So f of -5, -3, 0, 3, 4, 10, and we want to evaluate the piecewise function above by connecting the x values to the restrictions. Okay, so for the first one, we'll just say A. F of -5. So remember, this is our x value. So this says, when x is -5, what part of the piecewise function can we use? So we have to check our 3 restrictions and see where -5 fits. And we check the first restriction. Is -5 less than -2? And that answer is yes. Since -5 is less than -2, we get to plug -5 into this x value, or we get to substitute -5 into x plus 1. So that's all we have to do. This becomes -5 plus 1, which will give us -4. Okay, let's do it again. B. F of -3. So our x value is -3. Let's check our restrictions. Is 3 less than -2? And that answer is yes, -3 is less than -2. So again, we get to use this function x plus 1, where all we have to do is plug in -3 for x. And we'll get -2. Okay, again. C. F of 0. So when x is 0, we need to check our restrictions. Is 0 less than -2? That answer is no. So we can't use the first function. So then we check the next one. Is 0 in between -2 and 3? Is 0 in between these two x values, -2 and 3? And that answer is yes. And since 0 is between those two x values, the only output we get to use is 5. So f of 0 is 5. That's it. Oops, not too big. Okay. D. F of 3. Check our restrictions. Is 3 less than -2? Definitely not. That's out. Is 3 in between -2 and 3 and also included? So if I put a 3 in here, -2 is less than or equal to 3, which is good. Then, is 3 less than or equal to 3? Yes, it is. 3 is definitely equal to 3. 3 is less than or equal to 3. So since this works, we again get to use the output of 5. Okay. E. F of 4. When x is 4, which restriction does it belong to? Is 4 less than -2? Definitely not. Is 4 between -2 and 3? Definitely not. Is 4 bigger than 3? Yes. Since 4 is bigger than 3, we get to use x squared, which means we're going to plug 4 in for x. We'll get 4 squared, which gives me 16. Last one. F. F of 10 is 10 less than -2? Definitely not. Is 10 between -2 and 3? Definitely not. Is 10 bigger than 3? Yes, which means we get to use x squared again. So you'll get 10 squared, which gives us 100. So that's how we read a piecewise function. Given an x value, match it to its restriction, and that restriction should tell you which output you should use from the piecewise. And if it has an x, evaluate it at that x value. Plug it in, right? That's what we did. Okay, again. That's weird spacing, but okay, same thing. Okay, so we're gonna do it again. And let me see. Okay. Evaluate the piecewise function given the specific x values. So here, g of x equals x plus 4, and we're only allowed to use x plus 4 for values of x less than or equal to 1. Then 8 minus x, we are only allowed to use 8 minus x for values of x greater than 1. Okay, so get started again. A, g of -4. Is -4 less than 1? Less than or equal to 1? Yes, -4 is less than or equal to 1, which means we get to use x plus 4, which means plug -4 in for x, and you'll get -4 plus 4, which will give us 0. Okay? B, g of 0. When x is 0, is 0 less than or equal to 1? Yes, 0 is definitely less than 1. So again, we get to use x plus 4, plug in 0 for x, and you'll get 0 plus 4, so we'll get 4. Okay. C, g of 1. When x is exactly 1, is 1 less than or equal to 1? Yes, 1 is definitely equal to 1, which means we get to use the first function again. You'll give 1 plus 4, and we'll get 5. Last one. G of 3. Is 3 less than or equal to 1? Definitely not. Is 3 greater than 1? Yes. This means we get to use 8 minus x. So you'll get 8 minus 3, which will also give us 5. Okay, perfect. So given an x value, this is how you approach, this is how you evaluate a piecewise function. Okay, now on to graphing. Okay, graph the function g of x equals 1/3 x plus 3 for all values of x less than 3. And then negative x if our x values are greater than or equal to 3. Okay, so the way to graph a piecewise function is to make xy charts for each function. So here's what we're going to do. For the first one, I'm going to say x and y equals 1/3 x plus 3. Here's my xy chart. But so I know what numbers to pick, I'm going to put the restriction right above it. So we can only use 1/3 x plus 3 if I choose x values less than 3. So let's pick our x values. The restriction is telling us what x values to pick. It's telling us choose values less than 3. So guess what number I'm going to start at? 3. And we'll get to that in a second, what it means. Okay, so now I have to choose values less than 3. Well, before we pick more numbers, look at our function. 1/3 x. Do we want to graph a fraction? And that answer is no. So in order to get rid of this fraction, we're going to choose multiples of the denominator to plug in. So if the denominator is 3, what is a multiple of 3? 6, 9, 12, -3, -6, even 0 is a multiple of 3. And the reason we're choosing multiples of 3 is because it gets rid of the fraction. So let's go ahead and pick our numbers now. And we're going to choose numbers still less than 3. So I'm going to write down multiples of 3 that are less than 3. Yes. So next would be 0. 0 is less than 3. Next would be -3, -6, and -9. I can keep going, but I believe that's all that's going to fit. Okay. And now take all these x values and plug them in for that x up there. Okay. So if I plug in 3, 1/3 times 3 is 1, so you'll get 4. If I plug in 0, 1/3 times 0 is 0, so I'll get 3. If I plug in -3, 1/3 times -3 is -1, and -1 plus 3 gives me 2. Do you see a trend here? 4, 3, 2, 1, 0. Okay. But now, look at our restriction. It says x is less than 3, meaning, can I actually use 3? Does it say less than or equal to 3? No, it only says less than 3, which means since I can't technically use 3, this point is going to be undefined. Or better yet, when you plot an undefined point, it's going to be an open circle. Okay, let's go ahead and plot this one. So 3, 4, 1, 2, 3, 1, 2, 3, 4, an open circle. And then the rest will be closed. Actually, I'll do this. Okay. And then 0, 3, and then -3, 2, and then -6 and 1, and then -9 and 0. So here's what we look like. That's what the first part of our piecewise function looks like. Now, let's graph the second part, and we'll do the XY chart again. So, I'll have X and Y equals -X. Above it, I'll put the restriction. X greater than or equal to 3. And remember, if you're wondering what X values to choose, the restriction is telling us what X values to choose. It's saying pick X values greater than or equal to 3. And now, guess what number we're going to start at? 3. And now choose numbers bigger than 3. 3, 4, 5, 6, 7, 8. Sure. You can keep going if you want. I think our graph fits up to 10. And now plug these numbers in for -X, which means all your Y values are just going to turn negative. Okay, now this one says we can be equal to 3. So this point will be defined, meaning it will be a closed circle. So let's go ahead and graph that one. So first up is 3, -3. Which is right there. And then we'll go 4, -4, 5, -5, 6, -6, 7, 8, 9, 10. And our graph looks like this. And that is how you graph a piecewise function. That's it. Make an XY chart for the separate pieces, use the restrictions to tell you what X values to pick, and then just graph it. Okay. Again. All right. G of X is equal to X plus 1 for all values of X less than or equal to -3. So we'll start with that one. Same method. And we can only use this if my X values are less than or equal to -3. So again, it's telling us what to pick. We need to choose values less than or equal to -3. So we start at -3 and we go less than. -3, -4, -5, -6, -7. Why not? I'll throw a -8 in there. And again, plug all these numbers in for X. You'll get -2, -3, -4, -5, -6, -7. And this one says we can be less than or equal to -3. So this is defined. Okay, graph -3, -2, right there, and then plot the rest. -4, -3, -5, -4, and down. Okay. And then move on to the next one. This one says, for values of X between -3 and 4, the output will be -1. So let's make our XY chart. We're going to have X and Y equal to -1. And I'll put the restriction above it. We can only use values of X between -3 and 4. So this one is giving us the values to choose. It says pick numbers between -3 and 4. -3, -2, -1, 0, 1, 2, 3, 4. And no matter what x value I choose, the output, no matter what, as long as it's a number between -3 and 4, the output will always be -1. So -1, -1, -1, -1, and that. Okay, but take note, could we actually use -3? And could we actually use +4? And the answer is no, because these were less thans, not less than or equal to's. So this means that -3, -1, and 4, -1, these 2 points will be undefined. Okay, which means they'll be open circles. So let's plot that. All right, -3, -1. Right there, open. And then plot the rest, -2, -1, -1, -1, 0, -1, 1, -1, 2, -1, 3, -1. And then I get to 4, -1, and again, we'll have another open circle. And just connect. Okay, there's that. Now, XY chart for the last function. One half x, we can only use 1/2 x if x is greater than or equal to 4. So x and y equal 1/2 x. Hey, you're free. And we can only use this one if x is greater than or equal to 4. And once again, it's giving us the numbers to pick. We got to choose numbers bigger than 4. Bigger than or equal to 4. And once again, you have a fraction. We don't want to graph fractions. So we are going to choose multiples of 2 to get rid of this denominator. Multiples of 2 that are bigger than or that are greater than or equal to 4. And of course, we're going to start at 4. What else is a multiple of 2 that's bigger than 4? 6, 8, and 10. We'll stop there because that's all our graph can hold. Now take all these values and again, plug them in for x. So you're essentially just taking half of all the numbers. So 2, 3, 4, 5. And this said greater than or equal to 4, which means 4, 2 will be defined, which will be a closed circle. So 4, 2. Where are you? 4, 2. And then we'll just graph the rest of it. 6, 3, 6, 1, 2, 3, 8, 4, 6, 7, 8, 4, and then 10, 5. And there it is. Oh, not bad. All right. Last one to graph. Negative 2x plus 5 for x values less than or equal to 1. So again, x and y equals negative 2x plus 5. And we will choose values of x less than or equal to 1. Okay, once again, it's giving us the numbers to pick. So start with 1 and go less than. That's fine, 5 is enough. Plug these into the x values. So negative 2 times 1 plus 5 gives me 3. 0 plus 5 gives me 5. Negative 1 turns into 2 plus 5, so 7. 3, 5, 7, 9, 11, 13. Okay, and could we use 1? And that answer is yes. It said less than or equal to 1. So define. Okay, so 1, 3, right there, and then we'll plot the rest. Let's see, 0, 5, right there, negative 1, 7. Wait, oh, oops, sorry, that was way off. I did 3, 3, 1, 3, which is there. 0, 5, negative 1, 7, negative 2, 9. My graph takes off that way. All right, last piece. X and y equals x plus 2 for values of x greater than 1. Okay, so start with 1 and go greater than 2, 3, 4, 5. Get more values if you want, but this is enough. Plug them in for x, you'll get 3, 4, 5, 6, 7. Now, could we actually use 1 on this one? And the answer is no, because it was just a greater than. So 1, 3 will be undefined. Okay. Well, look at our XY charts. On the first one, 1, 3 is defined. On the second one, 1, 3 is undefined. Well, what happens here is something called a removable discontinuity, right? A removable discontinuity. To keep it in simple terms, if a point happens to be defined and undefined, well, all we're going to do is say that the point is defined altogether. To keep it even simpler, defined overrules undefined. So when we graph it, 1, 3 will still be a closed circle. And this only happens if the same point happens to be undefined and defined at the same time. So if it's that case, then 1, 3 will be defined no matter what. So when I graph this, it will still be a closed circle. And then we graph the rest. 2, 4, 3.5, 4.6, and then 5.7, and up and up and up. And there we go. So that is the easiest way to graph a piecewise function. Make an XY chart, follow your restrictions. Okay, last one, application. Okay. The table below shows state income tax for individuals filing a return in Kansas. Let's see. If taxable income is over $0 but not over $15,000, then that single person, that individual, will only pay 3.5% of taxable income. If the individual makes between $15,000 and $30,000, then the individual will pay $525 plus 6.25% of excess over $15,000. And then if the individual makes over $30,000, they will pay $1,462.50 plus 6.54% of excess over $30,000. So our job is to write a piecewise function to represent this tax bracket in Kansas. So we're going to create our own piecewise function. Okay, so that's step A. And we're going to call it T of X. Okay, well, it's giving us restrictions, if you haven't noticed. These two columns are the restrictions. So for the very first row, it says if we make over $0, but not over $15,000, we'll pay 3.5% of taxable income. So this one's the easiest function to make. So this means that whatever X amount of money we make, you're going to multiply it by the 3.5%, and that is the tax you're going to pay. So for the very first part of the piecewise function, and remember, we always convert percent to decimal. So you're going to have 0.035x. This represents the 3.5% tax on X amount of dollars between $0 and $15,000. And we can only use this function if we make between 0 and $15,000. Okay. Then for the next piece, it says if we make between $15,000 and $30,000, we will pay $525 plus 6.25% of excess over $15,000. Oof. All right. So what this means is that before we put it into the piecewise function, let's write out what it's telling us. So for the second one, it says, I'll call it 2. It says we'll pay $525 plus the 6.25% So always convert to decimal. 0.0625 on any money over $15,000. On any money over $15,000. Okay, so how do we represent over? And this was kind of like, what was it? That commission problem in 1.1. It was like the furniture store employee wants to make commission and they only make, or wants to make a decent paycheck, and they make 10% over, or sorry, they make 10% commission on sales over 7,500. And remember, we set it up as 0.10 times x minus 7,500, because x has to be greater than 7,500. So that's how we represent over. And it would also make sense if we said, okay, well, you have to make sales over 7,500. Well, another way to rewrite it is just subtract 7,500 to the left. And you would have x minus, power almost went out. Oof. All right, x minus 7,500 greater than 0. And this is the only piece you would plug in here. Okay. So that's exactly what we're going to do on this problem. All right. So it says 525 plus 6.25% of excess over $15,000. So what we're going to do is have 0.00625 times x minus 15,000. So that represents any amount of money over 15,000. Okay, and now we have to simplify it. So distribute the 0.0625. Minus whatever that is, let's see, 0.0625 gives me 937.50. And then you'll add these two. And you will get 0.0625x minus 412.5. And now we have found the second part of our piecewise function. And now we can only use this if we make between 15,000 15,000 and 30,000. Okay. And now we're ready for the third part. It says if we make over $30,000, then the tax due is $1,462.50 plus 6.45% of excess over $30,000. So it's going to be the exact same setup on what we did for the second part. So that's where we'll begin. We'll call this part 3. So we said 1462.5 plus 6.45% over 30,000. Times x minus 30,000. Okay. And just clean up from here. Minus whatever 0.0645 times 30,000 is, gives me 1935. Again, combine these two. And we get minus 472.5. And there is the third piece of our piecewise function. Okay. So 0.0645x minus 472.5. And we can only do this if we make over 30,000. Okay. There it is. There's our piecewise function. All right. So B, determine the graph of t of x. Okay. So let's make a small graph here. All right. So let's say, so my x values given are 0, 15,000, and 30,000. So maybe we can piece it with just those, right? So I'll go to B. And let's see what I can get away with. Let me see. 0. We can go by 5s, right? 5,000, 10,000, 15,000, 20,000, 25,000, and 30,000. Okay. Let me get out my calculator. One moment. Let's do this. Okay. So clear. All right. So the first thing I'm going to do is use the first part of the piecewise function. So we go back to y equals. I'm going to type in 0.035x. 0.035x. And then I'm going to go to my chart. Erase what's there. And we can choose numbers between 0 and 15,000 for this one. Okay. So maybe, I'm using the process that I did above. I'm making XY charts for every piece of the piecewise function. So here at 0, of course, you'll get 0. And then I'll just go by thousands, so 5,000. So I'll say 5,000, 10,000, and 15,000. All right. So that means over here, if I look, I have 0, 175, 350, and 525. I'm going to write those down because I want to know what the other y values are as well. So bear with me for a second. So this was x and y equals 0.035x. I did 0, 5,000, 10,000, 15,000. So 0, 175, 350, 525. Okay, and now I'm going to go back and try the second piecewise function. So let me see. Right here. 0.0625x minus 412.5. Enter second table. And for this function, we know we can use values between 15,000 and 30,000. So I'm going to go 15,000, 20,000, 25,000, and 30,000. Okay, and I'll write those down. So x and y equals 0.0625x minus 412.5. So 15,000, 20,000, 25,000, and 30,000. Okay, so 525, 837, 1150, 1462.5. Okay, and now, of course, the last function. Want to get this right, even though it's probably just going to be a tiny little sketch, right? All right. Type in the last piece. 0.0645x minus 472.5. Enter second graph. We can only use this one for values greater than 30,000. So we'll start at 30,000. And I'll go 35 and 40. I'm not going to choose much more. That's enough information. So green. X and Y equals 0.0645x minus, what was it? 47, 2.5. 30,000, 35,000, and 40,000. Okay. 1462.5, 1785, and 2107.5. Okay. We're ready to sketch our graph. Okay. There you are. Okay. So looking at my Y values from all three charts, I have 0, 175, 3. I'm just going to go by 500. Like I said, it's just going to be a sketch. Doesn't have to be too perfect. So let's say 500, 1,000, 1,500, and 2,000. Okay. So let's graph now based on our info. And for the blue one, we're at 0, 0. And then 5,175, not much higher. 10,350, a little higher. 15,525, just right above 500. So there's what we look like. Okay, and then for red, 15,525. So we start off at the same point. And then 20,800, a little higher. Let's say probably around there. And then 25,000 and 1150. I'll just go a little higher, somewhere around there. And then 30,000 and 14. So somewhere around there. And then for the green function, 30,000, 1462.5. So we start off here, and then 35 and 1785. So that would be somewhere out there, and then higher in 2000. So our graph will look something like that. Just a nice little sketch. Whew. All right. What's left? C. Find the tax due on a taxable income of $35,000. Okay. Well, simple enough. We're given X is $35,000. Which restriction does that fall under? $35,000 is bigger than 30,000. So all we have to do is plug in 35,000 into that X and evaluate. So we kind of did that already by my XY chart. Look at this. Right here. $35,000 will pay $1,785 in taxes. But let's write it out properly. We'll say T of, this is C, T of 35,000 will pay $17.85. All right, and that's piecewise functions. Yes, the applications are going to be a little crazy, but this is how you'll set them up. Just read it carefully. Okay, and that's it.